For our next question, we have Fatima owning 72 meters of fence, and she wishes to put fencing around the outside of her garden. And she plans to plant it against her house so there's no need for fencing along that side. Now Fatima wants to build 3 portions for her garden. You know, perhaps she wants to grow tomatoes and potatoes and roses. I don't know. But she wants to have 3 separate pens. And so she's going to need to put fence along here, 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 and here, as well as fence along there. Okay? And she's got a grand total of 72 meters worth of fence. So she wants to know first what's the largest total area she can have, and then also a second question will be this: what if Fatima specifically wants all 3 pens to each have an area of 96? So instead of shooting for the maximum, maybe she wants this to be 96, this to be 96, and this to be 96. What would be the areas that would, what would be the dimensions that would allow that to happen? So for part A, we just want to make this as big as we can, and for part B, we specifically want to know what measurements allow for each of the 3 pens to be 96 meters squared in area. Well, let's start with part A. For part A, we have the house, we have the 3 different pens, so what we really have are 4 widths and 1 length. Now we know that area is equal to length times width. The area of this overall rectangle will be length times width. We also know that L plus 4W is equal to 72, because she has 72 meters of fence. And what we want to do now is isolate this L. Okay? So if L plus 4W is 72, then we can subtract 4W from both sides and say L is equal to 72 minus 4W. And what we can then do is substitute this expression for L right into there. So it would be 72 minus 4W times W. Okay? So the area is 72 minus 4W times W. Now, we want to set this guy equal to 0 and this guy equal to 0. And the reason we want to do that, set those 2 factors each equal to 0, is in order to find the axis of symmetry. The axis of symmetry will be halfway in between these zeros because parabolas are symmetrical. So if you know that a parabola crosses the axis at a value of 0 and at a value of 18, then you know that halfway in between those will be where the vertex is. So 72 minus 4W equaling 0 means 72 is equal to 4W, which means W equals 18. Or we can let W equal 0. And we have these 2 values of W as our zeros. Our axis of symmetry has to be halfway in between. So it's 18 plus 0 divided by 2. And that equals 9. So what we're going to do now is substitute in a value for W of 9 and determine what our area would be. Now remember, from the previous page, area was equal to 72 minus 4W times W. Since our axis of symmetry is at W equals 9, that value of W will give us our maximum area. We plug it straight in. We get 72 minus 36 times 9, which is 36 times 9, which is 324. Forgot to put that in. Sorry about that. So 324 is our maximum possible area. Okay? Now, moving on to part B. Part B is a little bit different because it says each pen has to be 96 meters squared. So we have these 3 different pens. We need each of them to be 96. All 3 of them have an area of 96 meters squared. So what would the total area be? Well, the total area, the total length times width area, would be 96 plus 96 plus 96, which is 288. Okay? So since each pen is 96 meters squared, the total area would be 288. Well, go back a while ago. Remember what our area formula is. 72 minus 4W times W. So 288 is equal to 72 minus 4W times W. What we can then do is distribute. 72 times W is 72W. Negative 4W times W is negative 4W squared. We can then add 4w squared and subtract 72w from both sides, and we get this expression here. 4w squared minus 72w plus 288 equals 0. What we then want to do is common factor, because we're looking for the zeros. And we always common factor first. CFF stands for common factor first, and you want to remember that CFF is your BFF. Okay? So, we want to now find out two numbers that add to negative 18 but multiply to 72, and those numbers are negative 6 and negative 12. So we say w minus 6 equals 0, or w minus 12 equals 0. Well, if w minus 6 equals 0, then w is equal to 6. And if w minus 12 equals 0, then w is equal to 12. And you might be thinking to yourself, well, they can't both be right, which one is wrong? But in fact, they are both right. And let me show you why. Remember, we're looking to have 96 meters squared in each of the pens. So, if w is equal to 6, we know that length is 72 minus 4w. That would mean the length was 72 minus 24, which is 48. So if this whole length was 48, then each of these three would be 16. 6 times 16 is 96. 6 times 16 is 96. 6 times 16 is 96, and we would have used up 72 meters of fencing. 6 plus 6 plus 6 plus 6 plus 16 plus 16 plus 16. We would have used up all 72 meters of fencing, and we would have had 3 pens each with 96. Or maybe w is equal to 12. Well, let's see how that would work. The length would be 72 minus 4 times 12. That would be 72 minus 48, which is 24. So this whole length would be 24, meaning each of these individual 3 would be 8. Well, we would have used up all 72 meters of fence, because 12 plus 12 plus 12 plus 12 plus 8 plus 8 plus 8 is 72. And each of these would be 8 times 12 is 96. 8 times 12 is 96. 8 times 12 is 96. Each of our 3 individual pens would be 96 meters squared. So actually there's 2 possible answers.